So yesterday we started scientific notation. I made more of a little formalized note for you that you can keep and look back at. Okay, so when we're going from standard form, what that means is we're going from an actual number, like 5,000 or 2. Like that's what they mean by standard form, just the normal numbers that are on number line. That's our standard form. So we move the decimal point until it is in the right of to the right of the first non-zero digit. So for example, if I had 23,000, there we go, 23,000, I move my decimal point to the right of the first whole number. Okay, so that I would get 2.3. That's step 1. Step 2, you want to note the number of places in the direction that you moved. We moved 1, 2, 3, 4, so we have n equals 4. Now, if we move the decimal to the left, which we did, you're going to write the number as a, which we got was 2.3, times 10 to the positive 4. If we moved it to the right, that's when our exponent would have been negative. Okay, and then we remove any unnecessary zeros, which we did when I rewrote here. All those zeros went gone. Okay, so let's look at a couple examples. Right now on number 1, we're going from standard form to scientific notation. Where's my decimal point at on number 1? Where is it at right now? Right here, right? 0.0. It's at the end. Okay, where do we want to move that decimal point to? Behind the 2. Yep, so move it. 1, 2, 3, 4, 5, 6, 7, 8. So now we have 2.01. I got rid of all the other zeros. How many places did we move? 8. Now we move to the left, so is my exponent going to be positive or negative? Positive. Yep. Positive. To help yourself, I like thinking of it this way. If I moved 8 decimal places, if I went back, I would move in the positive direction. Is that what we would get back to? This says 8 places in the positive direction. Would we get back to this? Yes. Okay. What about number 2? It gives us our decimal point. Where do we need to move it to? Behind the 5. Okay. 1, 2, 3, 4, 5. So we have 5.1. We moved it 5 times. What's our exponent going to be this time? Negative 5. Okay, now if we went backwards, this is telling us we need to move 5 to the left. Would we get back to our original? Yes. Is this making more sense than yesterday? Okay. Questions on standard form to scientific notation? Okay, now we're going to go from scientific notation to standard form, which I believe is easier. Okay, so in this little format I gave you, it says in our scientific notation, you want to note whether n is greater than 0 or less than 0. So whether n is positive or negative. Okay, and then if n is greater than 0, you're going to move to the right, which is what our brain normally tells us to do. If it's greater than 0, we're moving to the right. If it's less than 0, so if it's negative, we're moving our decimal to the left. And then this last part is just telling you insert zeros in those empty spaces that we have after you move the decimal. Okay, so looking at number 1, we have 6.32 times 10 to the 9th. Is our exponent positive or negative? Positive, so which direction do I need to move? To the right. Yep. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now my decimal's over here. What do I fill in with those empty spaces? Zeros. All of those empty spaces we fill with zeros. So rewrite, do not leave your answer like that. We need to rewrite. Okay, so we have, how many zeros did I put in there? 7. Now just fill in those commas. Questions on that one? Okay, number 4. We don't have a decimal point to start, but what is it? 4.0, yep. Is our exponent, or our n, negative or positive? Negative, so which direction do I need to move? think some of us pointed that way. Yep, to the left. So I'm going to go 1, 2, 3, 4, 5, 6, 7. What do I do with my empty spaces? Fill in with zeros. And then can I leave my answer like that? Nope, rewrite it. We all have this one down. It's the one that we go backwards is what's throwing us off. So after you do this, when you're trying to decide if my exponent needs to be positive or negative, think backwards. Think if I'm going from here back to my original, am I going to the right or am I going to go to the left? Think of it that way. Okay? Questions on the front side? Okay, flip it to the back. Problem, main issue, the first part? Yeah. Thinking backwards? Okay. All right. Now you're going to see problems like this. Why do you think they threw these in here, in this chapter? Because you just learned about it, right? Those exponents, we just learned how to multiply those together. So when you're doing this, when we see this, a lot of us think FOIL. Not with times 10 to whatever. Okay? All you're going to do is you're going to take 3.5 times 7, and then you're going to take the two bases and multiply them together. So you're going to multiply them separately. So if I wrote that out, you would take 3.5 times 7, and then you're going to take 10 to the negative third times 10 to the fifth. So all I did was I split it up. Okay? What's 3.5 times 7? 24.5. And then what would our new base 10 be? 10 squared. Yep. What do we do with those exponents? Add them. Yep. Negative 3 plus 5, we get 2. Okay? That's in scientific notation. I also want you to write it in standard form. So how do we go from scientific notation to standard form? Remember, standard form, we want one number. Right, look at your exponent. Our exponent is positive, so which direction do I need to move? 2 to the right. 1, 2. Empty spaces we fill with zeros, so our answer would be 2,450. Okay, go ahead and try number 2. So when you're multiplying with scientific notation, what do? 6.5 times 8.7. What'd you get? 56.55. 56.55. What do I multiply next? Our bases? 10 to the 12th times 10 to the negative 15. What's our new base 10 exponent? Negative 3. Okay, is it okay to have negative exponents with scientific notation? Yes, that's the only time it's okay. So, to write in standard form, what do I need to do? Move which way? Left 3. 1, 2, 3. Fill in with zeros. So we get 0.0565. Questions on multiplying with scientific notation? Yeah.
So on number 2, I rounded up, so I put 56.6.
That's okay. Yep, that's okay. Any other questions with multiplying with scientific notation? Okay, let's move on down. Last thing, dividing with scientific notation. Raise your hand if you look at that and you want to cry. Okay, but do it the same way we did the top with multiplying. Okay, so how am I going to split this up? Yep. 3.066 divided by 7.3. And then base 10, we do 10 to the 8th divided by 10 to the 3rd. Okay, we split it up the same way as we did multiplication. What's 3.066 divided by 7.3? Did you get 0.42?
Yeah.
Okay. And then with our base 10, what do we get for our new exponent? 10 to the 5th. Okay. With that, what do we do now? Yep. Got to write it in standard form. So look at your exponent. Move the decimal to the right 5 times. So what is my answer on this one?
0.42000. Oh shoot.
Other way.
No,
42,000.
I did that. Add a 0. Because that decimal was there.
Okay. Now, was that as bad as we thought? No. Okay, go ahead and try number 2. When dividing with scientific notation, what do we split up? What goes together? Yep. The numbers, and then our base 10. What did you get for when you divided the numbers? 2.1.
Yeah.
Okay. Times 10, what's our new exponent? -5. Good. Now what? Standard form. Yep. Negative exponent, we go to the left. And fill with zeros. Sometimes when we move, we forget we're moving the actual decimal, so sometimes people put this as their answer. Is that a number?
No.
No, you gotta have that decimal there. Okay. Questions with scientific notation? That's it with scientific notation. Okay. Is there any other questions before I let you work? All right.